Hi, welcome. This class is the first class on patterns that result from the moon's rotation and revolution around the Earth. So we're going to start off by looking at two models. And what's the difference between these two animations? Now, I don't know if the frame rate is fast enough to pick up the difference, but in this one, the moon is rotating ever so slightly such that the same side always faces Earth. In this model, the moon is never rotating at all. So in one complete revolution, we get to see every single side that the moon has. The correct model is this one. The moon actually rotates once per every revolution. What that means is that the moon's rotation is equal to its revolution, which means that it takes about 29 and a half Earth days. Now, there's other ways, just to be pedantic, there's other ways to describe how long it takes the moon to revolve. Some people say 28 days, some people say 27 days. Really, it depends on what it's revolving in reference to. If it's in reference to the Earth, how long it takes to get around the exact and end up in the exact same spot relative to Earth, it's about 29 and a half days. If it's relative to the sun as it revolves around the sun, then it's about 28 days. And if it's relative to the stars on the distant side of the sun or the distant side of the Earth, that's about 27.3 days. So there's a couple different ways to answer this, but we'll take 28 days works for me. 29 and a half days, that's fine. Uh, the fact that the same side always faces Earth is a result of something called tidal locking, which occurs when gravity makes one side of an astronomical body always face the other. So, is the dark side of the moon always dark? In reality, no, it's not. I'm going to pause it right here. And the dark side of the moon is the side that's facing away from Earth always. Right here, it's not getting any sunlight because it's not facing the sun. But if you wait a little bit longer and pause it right there, then the dark side of the moon is facing the sun, and so it's lit. It's just that none of the light that's hitting that dark side of the moon is reflecting back towards Earth, so we never see it. So the reason it's called the dark side of the moon is not because it's always in darkness, it's because it's mysterious. So the term dark here is mysterious. A better way to talk about it would be to use the word far side. So here we have the far side of the moon, and this is the near side. This is the side that we're familiar with. If you'll notice, the back side has a lot more craters. We can get a better look at it right here. Many more crater impacts than the side that we're familiar with. That's because this moon kind of acts as a shield or a bodyguard to Earth, and any craters that would impact the near side would have to go through Earth to get there. So the Earth, in a sense, also acts as a bodyguard for the near side of the moon. All right, just as a review of the phases, this is something you had in 5th grade, but let's take one more look at it. This is a new moon. Here we have a waxing crescent, followed by a first quarter, a waxing gibbous. The full moon is when the entire lit side is reflected back towards Earth, then a waning gibbous, a third quarter, and a waning crescent. You should be able to identify these moons pretty rapidly just by looking at a picture. That's a skill that might take just a little bit of memorization or some flashcards, but make sure that you're able to do that. One more thing to note about the moon is that its orbit is on a 5-degree tilt from our ecliptic. So this red line here, that represents the plane on which the Earth travels around the sun. But the moon isn't on that plane. It's actually tilted ever so slightly on 5 degrees. And this is why we don't have eclipses every single month. If the moon were on the same plane as the ecliptic, then it would block the sun out every now and then, and it would fall into the Earth's shadow every now and then, or every month. But that's why we don't have eclipses. So at this point, what I want to do is try to see if you can't figure out what the moon phase is by its position in its orbit around Earth. So this is kind of taking moon phases from two perspectives: the orbit, the moon phase as seen from its position in the orbit, and the moon phase as seen from Earth. So if you look at this line, only people on this side of Earth, this half of the Earth, are able to see this moon. Everyone over here in Asia and Africa, they've rotated out of the field of the view of the moon. Now we can make them rotate into the field of view. Let's do that. All right, so here the Earth rotates underneath the moon like this, and every 24 hours. So right now, let's put North America facing the moon. So right now, New Canaan is pretty much directly underneath the moon. What would happen is we're going to see the moon's not going to look like a sphere to us. It'll look like a disk, like a two-dimensional disk. And on the left side of the moon, that's mostly going to be lit up. And then we'll see a small sliver right here of darkness. So it'll appear in the sky like this, where the left side is mostly lit because the left side of our view, if we're looking this way, is lit up. And then the right side over here is a little bit of darkness. This one, it's moved a little bit farther in its orbit. And so this one, the side of the moon that's facing us, half of it is in light and half of it is in dark. So that side, here I'll show you what I mean by that. Take the line. We see everything to the right of that line. Everything to the right of that line is what we're able to see. And half of it is dark, half of it is light. So that looks like this. The left side would be lit up. So I'm going to go through a couple of these, and you can kind of guess what they are. If you want to pause it and take a moment to figure out, you can do that. This is a waxing gibbous, where the right side is lit up. Right here, the left side is lit up, and the darkness is in light. It's in the shape of a crescent. So this is going to be a waning crescent, which would mean that it's over in this area. Okay, so what's this one? Barely any of it is lit up. That makes it a new moon, or just ever so slightly a little bit to the right of a new moon, since you can see a sliver right there. Okay, this is a waxing crescent. Not a complete full first quarter because there's a little bit left to go. There's still this crescent shape right there, but it's almost a first quarter. This is a little bit back in a few days earlier, so it's still a waxing crescent, but much less of it can be seen. Pause the video if you want to take a guess. This is a waning crescent, where the left side is lit up and it's the shape of a crescent. This is going to be a full moon. It'll appear right there. This one is a left side's lit up, so it's going to be waning, and it's the shape of a gibbous, so it's going to be right about there. Here we have a first quarter. Here we have a last quarter. Be over there. So the main pattern that you may have picked up is that all waning moons are lit up on the left side, and all waxing moons are lit up on the right side. This model does an excellent job summarizing everything, but it's important to note that it's relative to the sun. So if the sun is shining from down here on the bottom, as the moon progresses in its orbit like this, it will be growing in size, so we'll consider that waxing. And then as it's going down this way, it'll be waning in size, so it'll be getting less and less light. All moons going from a last quarter to a first quarter would be the shape of a crescent, and all moons going from a first quarter to a last quarter would be a gibbous. So this is a nice little diagram model to figure out exactly what phase the moon is based on its position in its orbit. Just some kind of neat information. Every full moon of every month has its own special name. Right now we're in January, so we're in the Wolf's Moon. Pink Moon is another one that's a nice song by Nick Drake. The Harvest Moon is something you may have heard of before. They typically have agricultural roots, but they're just kind of interesting. Now, if a full moon occurs twice in 1 month, that second moon is called a blue moon, and it's a rare event, hence the expression once in a blue moon. The last one to happen was 2015. The next one will be a year from now in 2018, and then a couple months later in March 31st. A really good one will be 2020. That'll be Halloween. And then in 2028, this is a really cool one. This is going to happen on New Year's Eve, but there's also going to be a total lunar eclipse, and it'll be a blue moon. You'll be about 25 or 26, so most likely you'll be attending a wedding then. Okay, that's kind of it. One thing I guess you can note is that sometimes the moon appears to be slanted, that the angle of the light is slanted. This is all relative to where the sun is in the sky, so when it's slanted like this, the sun is coming perpendicular to this terminator line right there, so the sun is way down here. This is the same moon just several hours later, and now the moon is about to set. The sun would be higher, so the sun would be up there. So a slanted moon is just a result of where the sun is. Okay, that's it for today. See you tomorrow in class.